Hello, chemistry students. Here are your corrections for page 241, questions 6 through 8. So in case you have some questions or need some help, this is your way to get that. Question 6 says, balance this equation, and A, interpret this equation in terms of numbers of molecules and moles, and B, show that the balanced equation obeys the law of conservation of mass. So again, I'm going to rewrite the equation first. So we have C2H5OH plus oxygen gas yields carbon dioxide and water. So this is a combustion reaction. So I have two carbons here, so I need a coefficient of 2 in front of carbon dioxide. I have 6 hydrogens, so I need a coefficient of 3 in front of water. So now I have 4 oxygens plus 3 oxygens makes 7. And I have 1 here and this, so I can make this 6, and there's 7. So there is my equation properly balanced. Okay. Now it says interpret this equation in the terms of numbers of molecules and moles. So we'll do molecules first, and these all would be molecules because these are all molecular compounds. Remember to interpret it in terms of molecules. My coefficients tell me the number of molecules, relative numbers. So I have 1 molecule of this alcohol plus 3 molecules of oxygen to produce 2 molecules of carbon dioxide and 3 molecules of water. So there's my interpretation in terms of molecules. To interpret this in terms of moles, again, my coefficients tell me my relative numbers of moles. So I have 1 mole of this alcohol plus 3 moles of oxygen to produce 2 moles of carbon dioxide and 3 moles of water. So now, letter B, show that the balanced equation follows the law of conservation of mass. So I need to figure out the mass of the reactants and the products. So again, to figure out the mass of my reactants, again, my coefficient on my alcohol is 1. So it's 1 mole of my alcohol and 1 mole, I'm going to use my molar mass, to how many grams that is. And again, to figure out my number of grams, I'm going to use my periodic table. I'm just going to use whole numbers for these to make it easy. So carbon's 12.011, so 12 times 2, because there's 2 carbons. 1.0079 for hydrogen, so 1 times, there's 6 of them all together, plus 1 oxygen at 15.999, so we'll call that 16. So that gives me 46 grams. So this is going to be 46 grams. So I'm just going to go ahead and put that over here too, so I kind of have it. For oxygen, I have 3 moles of oxygen using my coefficient. Going to use the molar mass of oxygen. And again, oxygen was 15.99, so we're going to use 16, but there's 2 of them, so it's going to be 32. And 32 times 3 is 96 grams. Again, I'm going to use 2 moles of carbon dioxide because that's my coefficient. I'm going to use the molar mass of carbon dioxide. And again, carbon is 12.011, so 12, and there's just one of them. And 2 times 15.999, which is 16, so that gives us a mass of 44. Times 2 gives us 88 grams. And then I have 3 moles of water. Again, use the molar mass of water to figure out how many grams. Again, hydrogen is 1 and there's 2 of them, so that's 2 plus oxygen is 16, so that gives us a mass of 18 grams. Times our 3 gives us 54 grams. Again, according to the law of conservation of mass, the mass of my reactants and the mass of my product should be equal. So 46 plus 96 is 139 grams. And 88 plus 54 is, did I do something wrong? 46 plus 96. Yes, I did that math wrong. It's not 142, or 139, it's 142. And then 88 and 54 is 142 grams as well. So, So we've proven that. So again, that's the math that you should have on your paper. Okay, that's the math I expect to see on a test or quiz if you're asked to do a question like this. Number 7, explain this statement. Mass and atoms are conserved in every chemical reaction, but moles will not necessarily be conserved. Again, mass and atoms have to be conserved because of the law of conservation of mass. But moles are not. Sometimes your moles might be equal to each other on both sides, but oftentimes they won't. Your textbook answered it this way. The number of moles of reactants and products depends on the chemical reaction. For some reactions, moles of reactants and products are equal, but this is not generally the case. So again, they're kind of saying that this depends on the coefficients in your balanced chemical equation. All right, number 8. Interpret the following equation in terms of relative numbers of representative particles, numbers of moles, and masses of reactants and products. So basically, this is very much like number 6. Okay, so in terms of particles, because this first one is an element, I'm going to interpret that one in atoms. This is a molecular compound, so that'll be molecules. This is an ionic compound, so that'll be formula units. This is a molecular compound, so that'll be molecules. So I have 2 atoms of potassium. I have 2 molecules of water. I have 2 formula units of potassium hydroxide. And I have 1 molecule of hydrogen. So the particle I use depends upon the substance itself. Moles, again, my coefficients. So I have 2 moles of potassium, 2 moles of water, 2 moles of potassium hydroxide, and 1 mole of hydrogen, because those are the coefficients in the balanced chemical equations. Now, masses of reactants and products. Again, this requires math. And again, this is the math I want to see. So, again, my coefficient on potassium is 2, so I have 2 moles of potassium. I'm going to use the molar mass of potassium to figure out the grams. Okay, so again, my potassium, 39.098, so I'm just going to use whole numbers, so it's going to be 39. And 39 times 2 is 78 grams. So again, I'm going to go ahead and write that above it. So my second one, I have, again, 2 moles because that's my coefficient of water. 1 mole of water is how many grams? And again, I'm going to use molar mass. So 2 hydrogens, which are 1 apiece. And oxygen is 15.99, so it's 16. So this is 18. Times 2 gives me 36 grams. So this is 36 grams. All right, so now I have 2 moles of potassium hydroxide. Again, because that's my coefficient. So potassium, again, was 39. Oxygen is 16. And hydrogen is 1. So I add those all together and I get 56. And I'm going to multiply that by 2, so I get 112 grams. So this is 112 grams. And then I have 1 mole of hydrogen. And 1 mole of hydrogen is how many grams? And again, hydrogen's 1, and there's 2 of them, so that's 2. So that's 2 grams. So this is 2 grams. So 78 plus my 36. Okay, 114 grams of my reactants. 112 grams and 2 grams gives me 114 grams of my products. And so I've proven that the law of conservation of mass is true. I hope that helps. If you had some questions, again, this is the work I expect to see on your papers for this. Have a great day. Talk to you tomorrow.